Good evening, everyone. A very warm welcome to all of you on behalf of ISRO's Space Tutor KIYE Foundation. This is Mayuri, one of the student coordinator from Kalam's Institute of Youth Excellence, and I'm delighted to share and welcome you all to the sixth lecture of STOCks, Space, Aerospace, and Futuristic Technologies. To everyone joining us live on YouTube from different parts of the country, welcome. We are so glad to have you with us this evening. Before we begin, let's make this session interactive right from the start. If you are joining us live on YouTube, drop a quick hello in the chat and let us know where you are joining from. We would love to see participants connecting from across India. That's the beauty of STOCks. Students, educators, professionals, and institutions from all over the country coming together with one shared goal to learn, explore, and grow. And that truly reminds us that curiosity for space and technology knows no boundaries. What makes this journey even more special is that it continues every single Saturday. Yes, every Saturday we come together to learn something new, connect with experts, and grow stronger as a community. Because the more we connect, the more we stay consistent, and consistency creates impact. STOCks is not just a lecture series, it is a platform, a community, and a mission inspired by the vision of Dr. APJ Abdul Kalam sir and his deep commitment to nation building. STOCks aims to ignite curiosity, inspire innovation, and shape the future of young minds. And our theme remains Space is the next destination. Let's explore it together. Before we move ahead, let's quickly understand what STOCks is all about. The S in STOCks stands for Space, Aerospace, and Futuristic Technologies. This initiative is dedicated to inspiring young minds toward exciting world of space, science, innovation, and emerging technologies. STOCks is a year-long online lecture series featuring 52 lectures, 52 speakers, 52 topics, 52 hours of knowledge and inspiration. This is not just a lecture series, it is a movement to build the next generation of scientists, engineers, innovators, and future leaders. And through STOCks, participants get the opportunity to learn directly from the top scientists and industry experts, explore career opportunities in space and defense sectors, build communication and critical thinking skills, earn certification through active participation. Sounds exciting, doesn't it? And we are just getting started. Now, before we move further, let's take a quick look at a short audiovisual presentation that highlights the vision and achievements of KIY. That was a glimpse of KIY, a platform where young minds are guided, inspired, and given the right direction to dream bigger. And now, to share what KIY truly means from a student's perspective, I invite one of our dedicated student coordinator, Shivani, to share her experience with KIY. Miss Shivani, over to you.
Thank you, Mayuri. I'm Shivani, an active student coordinator currently pursuing my BTech fourth year. Today, I'm happy to share my journey as a student coordinator at Kalam's Institute of Youth Excellence. Being a part of KIY has truly transformed me. When I first joined, I was not very confident or expressive. But through continuous involvement, I gradually improved my communication, leadership, teamwork, and coordination skills. Today, I feel more confident interacting with people and managing responsibilities. One of my first experiences was volunteering at Inspire Hyderabad 2K24 at Gachibowli Indoor Stadium, where I had the opportunity to listen to as Somnath sir. Later, I participated in Vignan Weber 2K25 on National Science Day, where thousands of students gathered. The event was honored by the presence of Honorable Chief Minister Revant Reddy sir and Honorable Raksha Mantri Rajnath Singh sir. During this event, I took responsibility for crowd management and I also got chance to witness live scientific models and an amazing drone shows. Another memorable experience was the Kalam Peace Convention 2025 at GMR Arena, held on the occasion of Dr. APJ Abdul Kalam's birthday. For the first time, I got the opportunity to witness astronaut Shubhanshu Shukla sir in person. Recently, during Vignan Weber 2026, I coordinated around 300 students from St. Teresa's School. Managing such a large group was a big responsibility and it gave me a great confidence. It was truly a fulfilling experience to see students excited about space science and innovative models. These are not just a number of events for me, but a series of opportunities that help me improve my communication skills, build confidence, and help me grow into a more responsible person who is confident, proactive, and ready to handle challenges. Through all these experiences, KYE has given me a platform to learn, grow, and discover my potential. I strongly encourage every student to join KIYE and make much more of such opportunities. Finally, I would like to express my heartfelt gratitude to our chief mentor, G. Satish Reddy sir, for mentoring us, and to Naresh Indian sir, founder of KIYE, for his invaluable mentorship and motivation, as well as to the ISRO family for their constant guidance and support. Thank you, Jai Hind.
Thank you, Shivani, for sharing your experience. Your words truly reflect the spirit, passion, and purpose of KIY. Now, let's bring in a little more energy before we move to our speaker. Everyone joining us live, if you are excited for today's session, drop a quick ready in the chat. And throughout the session, feel free to share your thoughts and questions in the YouTube live chat. We'll be taking selected questions during the Q&A session at the end. So stay active, stay curious, and stay engaged. And now comes the most awaited moment of today's session. It is my honor to introduce our esteemed speaker, Dr. Chandrika Kaushik ma'am, Distinguished Scientist and Director General, Production Coordination and Services Interaction, PC and SI, in Defense Research and Development Organization, DRDO. Within over 3 decades of experience, Dr. Kaushik has played a vital role in advancing India's defense capabilities. She oversees key verticals including armed forces interaction, industry interface, international cooperation, and quality and safety within DRDO. She has contributed significantly to strategic defense programs, including serving as Deputy Project Director for the Agni missile program. Her work has strengthened indigenous defense technologies and supported India's vision of self reliance. Dr. Kaushik's leadership, dedication to national security, and commitment to innovation make her a distinguished figure in India's defense sector. We are truly honored to have you with us today, ma'am. Participants, if you are excited to hear from her, drop a quick welcome, ma'am, in the chat. And now, without further delay, ma'am, the virtual stage is yours.
Thank you, Shivani. Am I audible?
Yes, ma'am, you're audible, ma'am.
Okay. A very good evening to all the young students who have joined online. And my compliments to the KIY Foundation. And I'm really happy to see this wonderful initiative, the young girls having so much of energy and raring to go. I would also like to compliment the office bearers of the KIY Foundation. the distinguished faculty members from the various engineering institutions, and to the young students. Today, I'd like to share with you a very different perspective on how actually engineering streams are contributing to tackling the real world problems in the aerospace arena and the very crucial role that the Indian industry is playing in this exciting journey, and all of you who are getting ready for joining this journey. Can you please load the presentation, Mayuri?
Yes, ma'am.
Yeah,
1 second.
yeah. Thank you. I request you to move to the next slide, please. Before we go any further, let us pause for a moment and remember the man whose spirit guides this entire lecture series. Dr. APJ Abdul Kalam, Bharat Ratna, our 11th president and our beloved missile man. Born in 1931 and with us till 2015, his words still light our path. He once said, "Look at the sky, we are not alone. The whole universe is friendly to us and conspires only to give the best to those who dream and work." Students, as we begin today's conversation, let Kalam sir's voice be the background music in our minds. Next slide, please. Let me take you through the roadmap for today's chat. We will move through 6 small sections. Firstly, why defense and space have become the most demanding engineering frontiers of our time. Second, the hard engineering problems facing us today in the area of propulsion, sensing, autonomy, materials, electronics, software. Third, I'd like to all of you to have a look at today's DRDO's defense portfolio, the work that we are all doing in the area of missiles, aircrafts, radars, soldier systems, etc. What the country, Bharat, has already built. Fourth, the frontier technologies, the new problem statements, hypersonics, artificial intelligence, quantum, directed energy, additive manufacturing, advanced stealth. Fifth is the space and geospatial domain, how orbital assets are reshaping defense, governance, and our economy. And finally, the most important part for you, all of you, what are the opportunities for students, startups, and MSMEs to partner with DRDO and how to begin? Next slide. Dear students, we are living in a brand new era and where speed, sensing, and software are rewriting the rules of strategic competition. Defense today is no longer a single domain context. Excuse me. The horizon is being reshaped by 4 big shifts: speed, hypersonic glide vehicles flying above Mach 5, compressing the decision windows from minutes to seconds. Transparency, be it in terms of the electro-optic sensors, the infrared sensors, the synthetic aperture radars, and the hyperspectral satellites, plus the space situational awareness, making the battlefield visible in near real time. Autonomy, unmanned platforms in air, land, sea, and under the water, working in coordinated swarms. And most importantly, the RF spectrum, de- leading to electronic warfare, cyber, quantum communications. These are some of the factors which are deciding who is seeing, what is being heard, and whatever you can see and whatever you can detect, whatever you can hear, that is the determinant of who can strike first. Today's R&D will lead to tomorrow's sovereignty. Next slide. Friends, engineering streams are what help us to solve the problems in the operational domain. We are facing six hard problems today, right now. Hypersonic flight, sustaining a controlled flight above Mach 5 with active cooling, scramjet propulsion, and thermal protection materials that survive intense aero heating. Second deals with stealth and survivability through shaping, ram coatings, IR signature suppression, and adaptive camouflage to defeat the multispectral sensors. Third deals with the spectrum dominance. How do we devise jam resistant, low probability of intercept communications and the ISA radars that can see drones the size of a hand? You have all seen the widespread use of drones in today's war. Everything is going towards autonomy, unmanned systems. How do we ensure that our unmanned autonomous systems will not be compromised by jamming being induced by the enemy? Autonomy at the edge. More and more autonomy, if we can bring in onto the platform for you by using AI, ML for navigation, target recognition, and swarm coordination. And that too, it should work even in a GPS denied environment. Counter drone and swarms using layered kinetic, RF, and directed energy responses that scale economically. And everything needs energy, power. So we need to have as small a size in which we can pack the power. So battery and propulsion systems for soldier kits, UGVs, AUVs, and the electric combat vehicles. These are the six hard problems where I would like all of you to see how you can contribute, where you would like to participate and support. Next. And industrial and production, how to manufacture them with quality and how can we enhance the scale of production in shorter timelines. Next slide. Mayuri, can you change the slide, please? Could you change the slide?
Done, ma'am. Next slide it is.
I don't see it on my screen. I'm seeing the same slide. Yeah, thank you. Right? And this is the kind of capability which no single agency can build on its own. We all need to work together, people in the academic institutions, the DRDO labs, industries, MSMEs, TDF. So to do that, to make sure that everybody can contribute towards this development process, we have multiple schemes like TDF, Dare to Dream, IDEX, etc. And from the academic institutions, we have created certain centers of excellence in IITs and other academic institutions where students like you can participate in the real life problems that we want all of you to look at and help us to solve them. And together we make the solutions that will work for our armed forces with the support of production of the industries and the quality assurance agencies. Next, please. I'd like to explain to you where is it that you all can contribute. Most of you might be aware of the technology readiness levels going from 1 to 9, where 1 is where we look at problems in terms of the basic sciences. And when we move towards 9, we have productionized solutions that are ready for deployment. And each of these TRL levels have a clear ownership level. And TRL 1 to 3 is where basic sciences, led by the universities, this is where the universities contribute. And we have multiple schemes from the research boards at via COEs, etc., where we are supporting research initiative in this place. And TRL 4 is where we are looking at 4 to actually 5, 6, 7, where we are engineering solutions in the laboratory and then gradually taking it to the industry, to the armed forces, through the industries. I'd like all of you to look at problems in the area of 1 to 3, 4, along with your seniors, your guides, your professors, to see where you can help us to solve some of these problems. Next slide, Mayuri. I'd like to tell you what we have already achieved, right? And I'd like you to be proud of this fact, right? India today has built a wide spectrum of indigenous defense capability and it spans across different domains. We have sea, land, air, space, different kind of radars for ground, ship, airborne users, fighter aircraft, AWMC, MRMR, AAA, missiles for various uses, surface to air to ground, and anti-ship, anti-tank, ballistic, etc. We have also developed various kinds of rockets, artillery guns, bombs, different kind of munitions for the naval warfare, sonars, which are the sensors, and torpedoes, which are the weapons for the naval warfare. Different kind of communication systems across various domains, armored fighting vehicles, combat engineering equipment, defense for nuclear, biological, and chemical systems. And today, all of you would be happy to know that more than 6 lakh crores worth of DRDO systems have already been approved for induction. This is the broad scale. I wanted you to have a broader understanding of what working for defense means. Please change the slide, Mayuri. I'd like you to look at some of the defense portfolios that we have done. In the area of missiles, all of you during Ops Sindoor must have heard about BrahMos, the supersonic cruise missile, which has been used very, very effectively. And this is something that can be launched from land, air, as well as the sea vectors. Akash, which is a medium range ground to base surface to air missile. Then Astra, which is a air to air missile which can be fired from various airborne platforms. Nag is an anti-tank guided missile which can be fired from a tracked platform. And similarly, we have many, many other systems, medium range, surface to air missile, MRSAM, which can be launched from ship or land. Each one of these systems represents the hard work of thousands of engineers, hundreds of partner industries, and decades of focused works. And friends, these are the systems that are battle ready and inducted into our armed forces. Going further, please change the slide, Mayuri. I'd like to share some more of our missile systems covering coastal defense, anti-tank, vertical launched, and air launched air radiation missiles. We have the naval anti-ship missile, which has two different variants, short range and medium range, both airborne, which can engage marine surface targets. The long range anti-ship missile is a ground mobile and can be used for coastal defense. The quick reaction SAM is our ground-based mobile air defense system, and it can be fired while on the move. So that means it can go along with a column of tanks, and in case there is an incoming threat from the aerial domain, this missile launcher steps fires a missile and scoots away, moves away. Long-range SAM is a long-range capability, vertical, operating at higher Mach numbers, and the vertically launched SRSAM can be launched from a naval platform for engaging incoming threats. It is very, very effective against sea skimming targets. Rudram series of missiles are air-to-surface missiles for anti-radiation and ground attack roles. Helena is a helicopter-launched anti-tank, and AMP-ATGM is a man-portable anti-tank missile. Truly, we are covering various theaters which are required to be taken care of. Next slide, Mayuri. Coming to the land vector, we have frontline armor, infantry mobility, and rapidly deployable battlefield infrastructure. So the first one is our main battle tank Arjun, which has been designed and built by our DRDO lab and being productionized by our ordnance factory, which has great firepower, mobility, and protection. And let me tell you, it is as easy to drive as a car. I have driven it and you all can also drive it. DRDO, work for the development system, and be a part of the great journey that we are all working for. The wheeled armored platform gives high mobility infantry transport, and you all see our terrain. We have multiple solutions for bridging. We have the Sarvatra, which can engage targets, which can be rapidly deployed by the mechanized forces. It has a 46-meter span, the lightweight footbridge, etc. Multiple bridging systems have been built. Next slide. Programs in our pipeline, the light tank, which is an air portable tank, which can be operated in high altitude and can be deployed in fast timelines. The future ready combat vehicle, as well as the armored protection. We have the active protection system, which can be deployed on our ATVs. And we are also working on the indigenous power packs, the engines and the transmission systems, which power these systems are also being developed indigenously for production. Next slide. Coming to the firepower, we have in the artillery, we have our advanced towed artillery gun systems, which is a long-range 155 millimeter howitzer. And let me share a proud fact. ATAX holds the longest firing range in its class globally. Our gunners can engage targets farther than any comparable system in the world. The second is the guided Pinaka, which is a precision-guided variant of the famous Pinaka multi-barrel rocket system. And when we have added the guidance mechanisms to it, we have moved it from an area saturation to a precision delivery. Both these systems showcase how Indian engineering can not only match but actually beat the global benchmarks. Continuing further, please change the slide. We have different series of ammunition which are required to be fired from the tanks and the artillery guns. So we have a whole portfolio of these ammunition, be it the Borle, the HE ammunition and all. We need ammunition for firing from the tanks and guns, right, students? Yes? How do we do that? So we develop, along with the tanks and the guns, we also develop the ammunition which is required to be fired from that. And the black ones that you see are some of the grenades which can be used in both offensive as well as defensive platforms. Let's move ahead. Moving ahead, the trend is moving towards autonomous, please change Mayuri, autonomous systems. Robots is something that you have been looking around along. We just had an AI summit in Delhi and you saw multiple robots. You have been seeing robots which are running marathons, which are trying to do everything that you would like them to do. And there are use cases for deploying them in the battlefield arena also. We have developed different kind of robots for which can handle if we want to neutralize a weapon which is left, if there's a bomb which needs to be neutralized and we don't want the people to go and do it, we can send a remotely operated vehicle, operate on it autonomously and see that the bomb gets diffused. So Daksh is a tracked teleoperated robot for hazardous object handling. And the confined space ROV is again a small ROV which can work in very, very small surfaces. Similarly, there are ROVs for surveillance, for firefighting operations, etc. And they help us to see where normal human eyes cannot see. We can send the robots in dangerous terrain, etc., to make sure that we can see where normally we'll not be able to. Please change. Moving from land to the airborne platform, right? All of you must have heard about Tejas, our light combat aircraft, which is our pride in the sky. This is a fixed wing combat and surveillance platform which has been developed entirely indigenously and is being produced. It is an agile, multi role fighter delivering the combat power for our Indian Air Force. Again, multiple agencies, more than 40 labs, more than 140 industries have worked towards development and production of this system. And the one on the right that you see with a small dome at the top is the airborne early warning and control system. These is our eyes and ears in the sky. So flying high, it can provide an aerial surveillance and battlefield information without going into the enemy terrain. So within from your own terrain, you can see what is happening and GIFs will give you the real-time input. Next slide, please. Moving forward, our future aerospace programs are even more exciting. We are building the LCA Mark II with much higher ranges and the twin engine deck-based fighter, which will provide warfighting capability to our naval warriors. So that means that aircraft can take off from a aircraft carrier from within the sea and come back and land back onto that platform. The AWMC Mark II, which will provide longer ranges for looking and getting your situational awareness, along with the advanced medium combat aircraft, are projects that are being worked upon. Next slide, please. Moving to the naval arena, right? How do we handle? Naval weapons and systems are required for blue water operations, and you are now seeing how important these are. All of you, when you know about what is happening in Hormuz, right? We are not able to move our assets. So somebody needs to help these commercial assets to move around, and that is where our Navy is helping them to escorting them, moving them around, right? So we have our torpedo Varnastra with a speed of 40 knots, which is wire guided, etc. And to protect our ships, we have anti-torpedo decoy systems. So different kind of torpedoes and different kind of sonars, which tell you if an enemy weapon is coming and targeting you. Please, let's move ahead. The radars are our sensors, and we have different kind of radars, right from a radar which will be able to tell you if a man is moving around, a radar which can look into the space 50 kilometers away, small radars which can tell you if a drone is approaching. So the whole variety of radars which are required for land, air, and a radar in the aircraft to tell you if an incoming weapon is coming looking at you, right? So the radar has to first identify it and tell the pilot so that he can The pilot can take appropriate countermeasures, fire weapons if required, and provide the necessary safeguards. So all this is done by our lab, which works on the radar, and we have a full family of radars which are required towards meeting this capability. Let's move forward. Our focus is now on different. I talked about hypersonics in the beginning. So we need scramjet engines, we need glide vehicles, and we need materials for providing thermal protection for those. For space, and which is what all of you are so enamored about, right? The S series. We need the ISR satellites, the satellite communication facilities, capability to navigate using the satellites, the global positioning system, GPS, we are all used to, right? Without GPS, nowadays you can't move anywhere. So we need to have, we are having our own satellite navigation systems, which helps in the PNT. Coming to AI, robotics, autonomy, there's a lot of work happening with inferences at the edge, work on swarms, then directed energy and electromagnetic high energy lasers, microwave weapons, EM rail guns. Then we need to have cyber has become the next warfare domain, right? We need a lot of capability in that area. And of course, you need advanced materials, the different kind of manufacturing skills that are required, a lot of work in the quantum technology is happening, and stealth and camouflage. Let's move ahead, coming to the technologies in the aerospace vertical. Aerostructure. So some of you who are working either in the aerospace students or the mechanical engineering students would find these very, very interesting problems. How do we make lighter airframes? Can we use composites for making those frames? There also, how do you bring in more strength while at the same time you keep them as light as possible? How do we bring in intelligence into this structures? How do we make them smart, fatigue and damage tolerant? How do we make sure that the aerodynamically the structure is the best, taking care of the vortex, the flow, the transition, low observation shaping? These are some of the real life problems that would be of interest to any engineering solution. Can we look at alternative power plants? How do we work on long endurance, high altitude UAVs, medium altitude UAVs, different kinds of problems in the guidance and navigation domain? The seekers that are part of any missile system, be it a RF seeker or an IR seeker, what can we do about it? How do we take it forward? And parachute and recovery mechanisms. These are some of the interesting problem statements that we are working on, and I'd like all of you also to be a part of it and contribute if you share the same passion. Next slide. The problem statements in the land domain span protection, lethality, and unmanned systems. I think you have moved. Oh, yeah, thank you. Right? So we need armor where we can increase the protection as we want. So we need modular armor. We can work with hybrid drives. We need more and more guided artillery with very, very precision guidance, precision guided shells and course correcting fuses. We need smart mines and capability to detect those smart mines along with logistics, CBRN, UAVs, etc. Next slide. Coming to the area of C4ISR, cyber. Okay, we have a naval domain also in between. So in the naval domain, we need sensors of longer ranges as well as we need better weapons, etc. Coming to communications, I think we are running short of time. I'll move faster. Coming to next slide. Communication, radars, and the electronic warfare we'd like to have as small a footprint for all of these and larger ranges so that it can help us better. Next. In the signal layer and the communications, we need compute software and quantum substrate for our future defense systems, for the command, control, communications, etc. So more and more AI is being used in this area, in area of computer vision, natural language processing, and decision support systems for use in defense. Next. For all these, we need materials, right? And we need materials that can support the soldier and sustain them through integrated ensembles. They need a situational awareness. We need exoskeletons which can help them carry heavier weights and protective gear. All this is required to support the soldier system. Uh, let's move forward. Let us move to space and geospatial. I heard Mayuri very interested in talking about space, and this is truly a national imperative. Space and geospatial system today are no longer just satellite hardware. They have become strategic infrastructure and which are central to our economy, our governance, and our defense. The next decade will derive very, very huge capabilities through this domain. Next slide. We'll skip the industrial revolution. Time is short. Go ahead. Next slide, please. Layered enablers of space and geospatial technology. We need positioning and Earth observation to AI-driven GNSS or positioning, right? We need 3D scanning, surveying, mapping. Use cases for this are huge, and the business processes cover acquisition, processing, visualization, decisions true. Look at the global impact in billions of dollars. Transportation, $623 billion, defense, 615, going on to fisheries, $9 million. Every sector that you can imagine today is using the space-based geodata. How do we capitalize it for our usage? Go ahead, please. Sensing from orbit is now becoming multimodal. We have different domains. We need visible, infrared, radar, multispectral, and signal intelligence. We need signal intelligence and electronic intelligence using different constellations and to give us actual picture of what is happening on the ground in real time for the defense forces. Next slide. We need to be able to sense early, as quickly as possible, to know if an incoming threat is looking at you. And that is where you have heard about Iron Dome, and you heard in US talk about a dome being created to safeguard the cities, right? This is where your sensors tell you if you are facing an incoming threat, and based on that, you can take evasive measures. So the space is becoming very, very important in identifying an incoming threat and helping you to deal with it. The next domain in space, go ahead, is with respect to communication. We have communications, you have heard about Starlink, and today you have not only communication, satellite communication, but also entertainment. Day-to-day, small satellites in the low Earth orbit, which are helping you to communicate with each other. Starlink is just one example. We need to build high throughput SATCOM payloads, which will enable in different bands, which will allow you to cover the huge area on ground for tactical and strategical users. Go ahead. Next slide. If we look at it, the sensor data should allow us to give an operational picture, and this can be done if we use multi-source fusion, combining the image data that you get from satellites, the signal intelligence, the electronic intelligence, etc. If you get all of it together and combine it into a single picture, this is where you will get multi-echelon data across various sectors. Next, please. Together, along with the industry, we are working on these problem statements through at different levels. And as I mentioned earlier, there are different models of engaging with industry. We'll not get into this at this juncture. Next slide. We have an interesting mechanism of technology development fund. We have centers of excellence. And there's a challenge which all of you might be interested in, the Dare to Dream challenge, where when we advertise certain challenges which anyone, any individual can take a part of it. So be on the lookout on our website and do participate in some of these challenges. You would find them really interesting. Next. What are the opportunities for you, right? I have shared with you the landscape, the challenges, the technologies, the systems that Bharat has built, and how DRDO works with all of the agencies towards building solutions. But the real question for all of you participating today is, where do you fit in all of this? How can you contribute, build a career, or start a company, or pursue research that matters to Bharat? Let me lay out a path, what is possible, what you can participate in. Your opportunity window is larger than before. Today's defense and space sectors are funded, policy-backed, talent-hungry, and waiting for you. Some big numbers. 3 lakh crores was the defense production value target by 2029. Right? There is a TDF corpus of 500 crores where each project can be funded about 50 crores. So these are some of the things. Plus, we have IDEX where up to 10 crore per startup for different challenges can be provided, right? Similarly, the InSpace, BIREC, and DST Inspire. Multiple options that are available to you for being a part of the solution space supporting us. Next. This is a challenge for some of you who want to start on your own. Some of the startups which will come from amongst you, 6 technical niche area with real customers, right? You have DRDO, MOD, ISRO, InSpace, Expos, and dedicated funding ladders. So you can look at any of these problems and see how to be a part of it and how to contribute. Next slide. For innovators amongst you, you can look at from how to be a part of the DRDO journey. You can join DRDO after your BTech and continue to grow, help us build solutions. You're seeing me as a part of the solution space, and you can also join and contribute towards that. Friends, before I close, here are 5 things, move ahead please, which I would like you to think about and carry with you beyond this lecture hall into the laboratories of your colleges. First, system and technology building skills. Learn the full stack. You should be aware of the design principles, simulation, prototyping, integration, testing. One slice alone is not enough for us to reach complete capability. Second, how do we actually solve problems? We should be able to look at problems from the first principles. We should be able to decompose the problem into smaller problems, be able to iterate it, and move ahead from an impossible into a sequence of merely difficult problems which you will be able to solve. Third, I want all of you to embrace the challenges which are cross-disciplinary, ambiguous. Sometimes the problems are half-defined. How do we actually translate them into actual small problems which are solvable and which are real engineering problems? Awakening your inner potential. All of you are Kalams. You have the heart and the problem-solving capability of Dr. Kalam. None of you is lesser than him. So I want all of you to walk that talk of Dr. Kalam, look at problems, look at real life problems, and help us to solve them. The technologies of 2047 Viksit Bharat will be built by some of you who refuse to give up and who really take up challenging problems. You have to make Bharat build its future. Every system, sensor, line of code, and any gram of material that you build will contribute towards this. Our end vision, friends, is a future-ready armed forces for Bharat, which is technologically superior, fully networked, and multi-domain and strategically autonomous. I would like all of you to be contributing towards that. And for doing that, I'd like you to take up difficult challenges and be a part of the problem solving. Dear students, dream as Kalam sir taught us, work hard, and I'm sure Bharat will rise. Thank you. Jai Hind, Jai Bharat. I'd be happy to take on any questions that you have. Over to you, Mayuri.
Thank you so much, ma'am, for that insightful and inspiring session. Your words have given us a deeper understanding of the real world applications of defense technologies and also space. And your journey has truly inspired us to think bigger and aim higher. Now, we move on to the Q&A session. Participants, this is your moment. You may now post your questions in the YouTube live chat. Ma'am, we have a question from the audience.
Please go ahead.
What are the main components of modern defense system? And it is from Jayant, ma'am.
Okay, Jayant, right?
Yes, ma'am.
Jayant, the modern defense components I just talked about. We have the land vertical, we have the naval vertical, we have the airborne vertical. Then we have the space, and cyber is becoming the next domain, right? So in all these domains, we need sensors, we need weapons to take care of them, and we need today's environment. We also need networking across all these verticals. We need to be able to see, hear together, understand a common picture amongst all the domains so that you can take action which will allow you to overcome the enemy. I hope I am able to answer your question.
Yes, ma'am. Should I continue with next question, ma'am?
Please go ahead.
So we have Hasini, one of our student coordinator, and she wanted to ask you, ma'am. Hasini?
Good evening, ma'am. I'm Hasini. Ma'am, with multiple DRDO labs working on different domains, what are the key challenges in integrating their research into unfired, reliable, and mission critical systems, ma'am?
Okay, challenges are integrating the solutions across various domains, but it's actually not a challenge. Actually, it's only a question of need to work in very tight timelines, right? So integrating the effort across various stakeholders working together, which meets the demands. So our only challenge is to work faster and deliver solution against the tight timelines. Working together is not really a challenge. Any system that we work on are multidisciplinary, and where in any big solution, whether it is a tank or a missile system, not more, at least 10 labs would be working together. So we have a well-established matrix kind of a structure where the different laboratories contributes towards helping us build the solutions together. So those specific processes and systems are pretty well established, which enable us to work together within the labs and along with the industries.
Thank you, ma'am.
Ma'am, we have another question from Siri.
Go ahead.
Hello, ma'am. I am Siri from Aeronautical Department. What are the current major challenges in India's aerospace and defense systems that young engineers can work on?
Okay, so problems in the aerospace and defense sector. We need aircrafts which will allow you to fly at larger speeds. We need lighter aircrafts which can carry larger weapons. We should be able to fire the weapons from a larger standoff distances. That will allow our pilots, so that those are, and the materials that go towards it, the sensors that are, I talked about some of the sensor, the airborne radar, which should be able to see larger distances. We need weapons which can go for longer ranges. So those are some of the airborne space challenges. And you said aerospace and what was and defense, you said?
Yes, ma'am, in aerospace and defense systems.
Okay. And we would also like to see how to use autonomy so that we don't endanger any person fighting as a part of it. Without exposing them, can we have autonomous systems which will allow our people to go without exposing our people? How do we go fight the battle? And some of these engineering solutions that we need in terms of materials, the space vertical, I did present as a part of my slides, right?
We have Shivani, one of our coordinator, to ask the question now. Shivani?
Good evening, ma'am. I have a question related to modern warfare. How is the role of multi-platform missile systems like naval, air, and land-based are evolving with AI integration, ma'am?
So I think today AI is being used across various weapons. A lot of how do we detect based on our seekers, based on what they have seen earlier? How do we improve the learning from that? So we can have especially the imaging seekers, if they have the data of the earlier images, can that be used for helping them to guide the seekers better? So this is just one example of AI. Similarly, based on the earlier data that is available, everywhere there is a use case for AI based on the data that is available from the real life world, real life warfare situations.
Thank you, ma'am.
Ma'am, with your permission, we would like to present the next question from audience.
Go ahead.
What are the major threats in cyber defense? That is from Shivani.
Okay, cyber defense is a very, very critical area. And I think part of the issue is our dependence on some of the hardware and the major backbone software which comes from there, right? So you are aware of some of the malwares, some of the Trojan horses, some of the breaches that have happened. So that is something that, and some of I'd like some of you computer science students to be working on those real life problems, helping us to make solutions of our own within our country so that the dependency on any foreign OEM for those kind of solutions would gradually diminish.
Ma'am, there is another question from Neeraj Begum. India's system uses ground cell towers. The moon has none. What aerospace infrastructure would you need to broadcast an emergency alert to astronauts scattered across lunar base?
Uh, I understand this. Do I understand the question rightly? That how do you transmit a alert to astronauts on the lunar,
Yes, ma'am.
right? Base. Okay. So mostly whenever our astronauts go abroad, whether it is on Earth or the ISS and all, there is always a link with the ground stations which are available on the ground. So using those communication links, we are in a position to transmit any alerts, or not only alerts, any other communication also. I think sometime back, some of you might have seen how one of the astronauts went out and fixed a problem on the ISS, the space station. There was some issue which the astronaut walked out and helped to resolve it, right? So always the astronauts would be in touch with the ground control station and would be able to get the information in time, right? So that the two-way communication link is invariably a part of it.
Thank you, ma'am, for patiently answering the questions and encouraging young minds with such clarity and ma'am. And thank you to all our participants for your enthusiastic and active participation. As we come to the close of this wonderful session, I now invite Ms. Hasini to deliver the vote of thanks. Hasini, over to you.
Respected dignitaries and esteemed speaker and dear participants, very good evening everyone. On behalf of KIYE Foundation, I extend our heartfelt vote of thanks to Dr. Chandrika ma'am for sharing her valuable time, knowledge, and insights with us today. Your words have truly inspired us and provided a deeper understanding that will guide us in our learning journey, ma'am. We are grateful for your presence and for the clarity, motivation you have given all of us. Your experience and the guidance will surely having a lasting impact on every participant here. I would also thank to our organizing team, volunteers, and all the participants for making this event successful. Once again, thank you, ma'am, for your enlightening session. We look forward to more such sessions, opportunities in the future, ma'am. Thank you, ma'am. Jai Hind.
Jai Hind. My best wishes to all of you for a very, very bright future contributing towards self-reliance and the defense of the country. Thank you. All the best.
Thank you, Hasini, for those warm and thoughtful words.
Thank you. I'll log off now.
Ma'am, 1 minute, ma'am. On behalf of KIYE, I kindly request Dr. Chandrika Kaushik, ma'am, to attend the physical event on 15th October 2026 in Hyderabad, marking the birth anniversary of APJ Abdul Kalam, sir.
Okay, I'll try and be there.
Thank you, ma'am. Thank you so much to the audience and everyone who joined us today. And we would love to have many more sessions like this. Thank you. Jai Hind.
Okay, bye-bye.